Question number 56 says that consider the planes P1 x plus y plus z equals 0, P2 x minus y plus z equals 0. The lines L1 x minus 1 upon 1 equals y minus 2 upon 1 equals z plus 1 upon 1, and L2 equals x plus 1 upon 1 equals y plus 2 upon 1 equals z minus 1 upon 1. A part says that if an equation of the plane passing through the intersection of P1 equal to 0 and P2 equal to 0 and parallel to line L1 is alpha x plus beta y plus gamma z plus delta equals 0, then, so students, we know that any plane passing through the intersection of P1 equal to 0 and P2 equal to 0 is given as P1 plus lambda P2 is equal to 0. So this equation will be 1 plus lambda into x plus 1 minus lambda into y plus 1 plus lambda into z equals to 0. So students, we have this particular plane parallel to the line L1. So if it is parallel to the line L1, that means the direction ratios of this line L1 dot product with the direction ratios of the normal vector of the plane, the answer will be 0. So we have 1 plus lambda into 1 plus 1 minus lambda into 1 plus 1 plus lambda into 1 equals 0. From here you will get lambda equals minus 3. So if lambda is equal to minus 3, the plane is minus 2x plus 4y minus 2z equals 0, which can be written as x minus 2y plus z equals 0. Students, the given plane is alpha x plus beta y plus gamma z plus delta equals 0. So by comparing these two planes, I will get alpha upon 1 equals to beta upon minus 2 equals to gamma upon 1 equal to some constant k, and clearly delta is equal to 0. Okay, so we have delta equal to 0, correct. Beta upon alpha, clearly from this equation it is minus 2, correct. Beta upon gamma, again minus 2, correct. Alpha plus beta plus gamma plus delta equal to 0. So we have alpha equal to gamma equal to k and beta equal to minus 2k. So definitely alpha plus beta plus gamma plus delta is equal to 0. Alpha upon gamma equals 1. Yes, alpha equal to gamma equal to k. So alpha upon gamma is 1. All the 5 options matches correctly. So A matches to P, Q, R, S, T. Fine. Let us move on to B part. B part says that if the equation of plane parallel to plane P1 equals 0 and containing the line x minus 1 upon 1 equals y minus 2 upon minus 2 equals z plus 1 upon 1 is again the same, then we have to again match the following options. Students, the equation of plane parallel to P1 can be assumed as x plus y plus z equal to lambda. So we have this particular plane containing the line L1. So we have 1, 2, minus 1 lying in this plane. 1 plus 2 minus 1 equals lambda. Lambda equals 2. The plane is x plus y plus z minus 2 equals 0. By comparing with this particular plane, I'll get alpha upon 1 equals to beta upon 1 equals to gamma upon 1 equals to delta upon minus 2 equals to, let us say, k. So we have alpha equal to beta equal to gamma equal to some constant k, and delta is equal to minus 2k. Definitely P is wrong, Q is wrong, R is wrong, S is also wrong, T is the only option which is correct. So B matches with only T. Okay, let us move on to C part. Going further with C part, it says that equation of plane containing the line L1 and L2. So if I need equation of plane containing line L1 and L2, definitely I'll write x minus 1, y minus 2, z plus 1. Then I'll write a2 vector minus a1 vector. So that is 2, 4 minus 2. And then I'll write the direction ratios of either of the lines because they are parallel. So 1, 1, 1. The scalar triple product of these three vectors will be 0. Okay. So we will get, after solving, 3x minus 2y minus z equals 0. So we have, on comparing, alpha by 3 equals to beta by minus 2 equals to gamma upon minus 1 equals to k, and clearly delta is equal to 0. So students, we have delta 0 correct, beta upon alpha is minus 2 wrong, beta upon gamma minus 2 wrong, alpha plus beta plus gamma plus delta. So alpha is 3k, beta is minus 2k, gamma is minus k, and delta is 0. So definitely S is correct. Alpha upon gamma is 1, wrong. So C option matches with P and S from column 2. Okay, let us move on to D part. Again, it says that equation of plane passing through intersection of P1 equal to 0 and P2 equal to 0 and parallel to line L2 is again the same plane. Students, it is very clear that L1 and L2 are parallel. So part number A and part number D are exactly the same. So directly I can write that x minus 2y plus z equals 0. The answer will be definitely same. So D matches with again P, Q, R, S, T, all 5 options. D option is exactly same with A part. That is parallel to line L1. Over here we have parallel to line L2. Okay, and L1 and L2 are already parallel. So we have the same answers. Let us move on to question number 57. So let us start with question number 57. A part says that f dash x is equal to x power 4 minus 5x square plus 4. Then we have to match the entry A of column 1 with PQRST of column 2. So let us start. F dash x is already given to us. X power 4 minus 5x square plus 4. So easily factorizable. X square minus 1 into x square minus 4. X minus 1 into x plus 1 into x minus 2 into x plus 2. So let us analyze fx with the help of f dash x. X is minus 2, minus 1, 1 and 2. Depending on the sign of f dash x, fx is either increasing or decreasing. So positive, negative, positive, negative, positive. Students, it is very clear that f dash x has increases then decreases, maxima, again maxima over here, and at these 2 points we have a minima. So 2 points of local maxima, 2 points of local minima, P and Q are correct. Correspondingly, T is wrong. Fx is always increasing in the interval 0 to 1. Definitely from minus 1 to 1, f dash x is positive, so fx is increasing. Correct. Fx is always decreasing in the interval pi to 3 pi by 2. Now pi is a value which is greater than 2. Pi to 3 pi by 2, fx is clearly increasing because f dash x is positive. So S is wrong. PQR is the correct match for option number A. Okay. Just check the sign of f dash x and comment on fx. That is the whole scenario for question number 57. Let us move on to B part. F dash x is x square minus 1 will come out common. Integral 0 to x square e raised to power t dt. So e raised to power t has integral e raised to power t only. So this is x square minus 1 multiplied by e raised to power t from 0 to x square. So that will give you x square minus 1 into e raised to power x square minus 1. That is x minus 1 into x plus 1 into e raised to the power x square minus 1. So students, clearly we have two critical points, x equals 1 and x equals minus 1 respectively. From the third bracket, I will have x equals to 0 because e raised to power x square equals to 1 means x square equals to 0 or x equals to 0. So three critical points, minus 1, 0, 1. Talking about the sign of f dash x, it is positive here. Then it will become negative here. On the left hand side and the right hand side of 0, we have e raised to power x square. So x square does not change the sign when x approaches to 0. That is why e raised to power x square minus 1 will never change its sign. No doubt it is a critical point. The sign will not change. That means it is a repeated root. So negative and then positive. So from positive to negative, we have a point of maxima. From negative to negative, that means the sign does not change along a particular critical point. This is the point of inflection. Then we have from negative to positive, the point of minima. P is wrong, Q is wrong. Increasing in the interval 0 to 1, wrong because it is negative, so fx will decrease. Decreasing in the interval pi to 3 pi by 2, wrong. Why could fx has 2 points of local extremum? Very true. 1 point of maxima, 1 point of minima, 2 points of local extremum. Option number T is the only correct match for B part. Okay. Let us move on to C part. C part is fx equals sin x minus cos square x. X belongs to 0 to 2 pi, one complete cycle for all the trigonometric functions. So let us start it straight away. Fx is sin x minus cos square x in one complete cycle. F dash x will be differentiation of sin x is cos x. This will be minus 2 cos x into minus sin x. So this is 2 sin x cos x plus cos x. So cos x is common. 2 sin x plus 1. So if I put f dash x equals 0, I'll get 4 points. Pi by 2, 3 pi by 2, pi plus pi by 6 and 2 pi minus pi by 6. So very sure if we have 4 critical points, we'll have 2 points of local maxima, 2 points of local minima,
which are equivalent to pi by 2, 7 pi by 6, 3 pi by 2 and 11 pi by 6 in the increasing order. So let us have the axis of x once again. Let us analyze it. Let us say this is 0, this is 2 pi. So pi by 2, 7 pi by 6, 3 pi by 2, 11 pi by 6. So students, definitely positive here, negative, positive, negative, positive. Total 4 points of extremum, 2 points of local maxima and 2 points of local minima. This is going to be maxima and this is going to be maxima. The other 2 points are going to be the points of minima. Now P is correct, Q is correct from 0 to 1. So from 0 to 1 it is definitely increasing because it is increasing in 0 to pi by 2. As simple as that. Decreasing in the interval pi to 3 pi by 2. So you can see that pi is slightly left to 7 pi by 6. But after 7 pi by 6 till 3 pi by 2 function is increasing. So that is wrong. Y equal to fx has 2 points of extremum. Obviously if PQ are correct, T cannot be correct. So PQR is the final match for option number C. Okay. Let us move on to D part. Okay. D part says that fx is equal to x square into sin x plus 2x into cos x, where x belongs to 0 to 2 pi. Again, one complete cycle. So fx is x square sin x plus 2x cos x. So let us calculate f dash x straight away. 2x sin x plus x square cos x plus 2 cos x minus 2x sin x. So first term and fourth term are cancelled. Positive and negative. This is cos x into x square plus 2. X square plus 2 can never be 0. So f dash x is equal to 0 at x equal to pi by 2, 3 pi by 2. T is correct. P, Q both are wrong. Fx is always increasing in the interval. So f dash x is positive in the interval 0 to pi by 2. Definitely R is correct. S1, pi to 3 pi by 2. That means the third quadrant. Obviously decreasing. Correct. RST is the final match for D part. Let us move on to next section which contains integer type problems.